Hello. Hello, and welcome back to Algebra 1. Again, my name is Joey. I'm going to be your math teacher for today. Again, if this is your first time tuning in, or if you're just or if you're a constant viewer of this channel and of this OneClass live stream, I just want to welcome you again. Here at OneClass, we're dedicated to helping you either catch up or get ahead in school, and you can access our free videos online, specifically for math and for chemistry. Online at oneclass.com/livestream. So you're able to access this wherever you are. If you have any questions during any time during my lesson, feel free to type in the chat, and I'll try my best to help you answer those questions. But without further ado, we're going to jump into the lesson. Actually, before we do that, just a little bit about me. Again, my name is Joey. I've been working for OneClass for a little bit, actually, over 2 weeks now, which is awesome. Glad to have me on board. But I'm currently a teacher candidate at York University, hoping to teach a secondary school. So specifically in science, so in chemistry and in music as well. But I'll have my math teachable by September as well. So that's kind of my background as I'm coming to OneClass with. And I really hope that either you at home or your kids, if you're watching, you'll be able to enjoy the stream and find this somewhat meaningful in terms of learning. So I'm going to just get started, and we'll just do a little review of what we did last time. Okay, so what we did last time was we reviewed this concept of, we did subtraction of integers. So if we were subtracting two integers, and I'll do a little review here. So if I gave you, for example, -3 minus 4, you would be able to answer that. And how we would do that is that we would try to find similarities with subtraction and addition of integers or numbers. So if we had -3 here, minus 4, what we get in this point is, if I have these two negative signs, and I had this rule where if I have two negative signs right beside each other, what I could do is I could fuse these, and two negatives make a positive. So I have -3 plus, and then just 4 here in this case, which would equal, and this would change my problem into addition problem, which we're much more familiar with. So -3 plus 4 is obviously just +1 here in this case. What we also did was this was subtraction of integers. So I'm going to write subtraction. And this is just a little review before we jump into this. And this will be important as well, because we're going to have to use these rules for the distributive property, which we'll talk about today. We did multiplication. I spelled that wrong. We did multiplication of, this is subtraction of negative numbers. This is multiplication of, and I'm just going to do a quote, says of negative numbers as well. And what we did was, if I, for example, I have -5 times +3, for example, we would have, in this case, 5 times 3, we know it's 15, but is it positive or negative? And we had this rule where we had, if it was negative times a positive number, our outcome would be, our product would be negatives, right? So in this case, 5 times 3 is 15. It's actually -15 here. We have one negative, one positive. This would be -15. We multiply two negative numbers together, let's say -5 and -5. We would get 5 times 5 here is 25, and two negatives make a positive. So if you multiply two negatives, you get a positive number. And if you multiply two positive numbers, you're going to get a positive. So that's what we did last lesson. And we also did division as well. So let me write that down. We kind of stopped at division and then it's just negative numbers, right? So if we had something like -10 divided by 5, for example, we would be able to solve this. You can visualize it by, you're simply dividing the two numbers. So 10 divided by 5 would be just simply 2. Or you could rewrite this as 5 times some number equals -10, right? You could rewrite a division problem. You could rewrite it as a multiplication problem as well. So how we would do that is, again, 5 times what equals -10? 5 times 2 obviously equals 10, but is it positive or negative in this case? I have one positive number, which means my answer will have to be negative. So this is -2 equals -10 in this case. And I think the case we didn't actually look over is this case here, and I'll do this really quickly before we move on. If we had, for example, -16 divided by -4, what would we get? So in this case, we have two negative numbers. We have negative 16 and negative 4. We could rewrite this as a multiplication. We have negative 4 times what number equals negative 16, right? So a lot of people might be tempted. I know students, oh, 16 divided by 4 is simply 4, and it's just negative, right? Because it has to be minus. But a lot of times that is not the correct answer. And how we know this is because 4, if I have a negative already, negative 4, if I have one negative number and I need to produce a negative number, I would have to multiply by a positive number. So negative 4 times 4 would equal negative 16 in this case. If I had negative 4, if I had negative 4 times negative 4, I would get positive 16, right? I wouldn't get negative 16. So in this case, the answer here is simply 4, so positive 4. So two negatives here, I get a positive. And you can think of it as you're canceling out these negative signs, and 16 divided by 4 is simply 4. And that's how we would do division of negative numbers. So that was just a little review of what we did last week. But what we're going to do now is we're going to jump into some new material. So let's scroll down here, make some space. And just a little overview of today's lesson. What we're going to do is we're going to work on, I'm going to introduce you to the concept of the distributive property. So this is distributive property. We're also going to do combining like terms as well, so simplifying some variables. And then if we have time, we'll go over percent of change. And percent of change we won't spend that much time on just because it's not as relevant. It's more relevant for like kind of word problems that you find in Algebra 1. But most of the time, distributive property and combining like terms are very, very important concepts that we'll probably focus on more so. So when we talk about distributive property, it's this concept where we're multiplying something into a bracket. So I'm going to use question 1 for example, and we'll define distributive property right after. But I'll do a question so it might help you visualize what's going on. And I'm gonna describe distributive properties using layman's terms. So in some type of form that you might be more familiar with rather than the technical term. Because in Algebra 1, again, there's a lot of abstract new things in terms of variables, equations, linear equations that you might not be familiar with. So I'm going to try to use terms that are somewhat more familiar for you folks at home. So I'm going to do question 1, and this is question 1 here. So I'm going to write here, this is negative 6. Negative 6 is bracket a plus 8. So how do we distribute? What is this concept of distributive property? So when we talk about distributive property, it's this term. It's about distribution. So what does the term distribution mean in everyday terms? Distribution means that you have things that are being handed out or they apply to everything, right? So I'm gonna write here distributive property. So the word distribution. I'm going to actually Google this because distribution, I'll give you a Merriam-Webster definition here. Distribution means here the act of process of distributing. That doesn't help us, but let's do, so maybe just distributing. So you're dividing among or several or many. So, or actually I'm going to use the second definition, which is the spread out. Spread out. So as to cover everything. So this is the technical definition for the word. This is for the word distributing, which is very close to the word distribution. And this is from Merriam-Webster. So Merriam-Webster, so again, they define the word distributing as to spread out so as to cover everything. So what does that mean? So what it means in terms of math terms is that when we have something that's multiplied into a bracket, so it happens when there's a scenario here, and I'll do this in red, where we have, when do we do the distributive property, or what is it first? So I'll talk to you about what it is. What the definition in terms of math terms is when you are distributing or when you are multiplying specifically. So it's specifically to multiplication. You're multiplying a term here, or a variable. It could be a variable, could be a number. This would be I'm going to call this a term. So this here would be a variable, or or number, doesn't really matter what goes in. So if you have a term multiplied I'm going to multiplied, and then by something in brackets. So by something, this could be anything, by anything. I'm going to write here anything in brackets. So anything in brackets. So what does that mean? So it means in this case that for this question here, I'm going to switch back to black here. -6 times is a plus 8, right? And basically how we approached this before was we use this concept of BEDMAS, right? PEDMAS for you Americans. We had this concept of, oh yeah, we'll do the parenthesis first, and then we'll move on and we'll multiply, right? And that's usually the case. But in this case, like, if you look at the parenthesis here, whatever's in brackets, we have here a plus a. What can we do with a plus a? We don't know what a is. A is an unknown. But what we can do is we can't do anything to anything in brackets. So we have to move on to this concept of multiplication. So I'm going to rewrite this. -6 times a plus 8. And basically what we're doing with the distributive property is we are spreading out so as to cover everything. We are spreading out this -6 in this case to cover what's inside the brackets. So what does that mean? So it means here that this -6 or this -6 here, this term, is going to be multiplied to the first term here, to a, and then it's also going to be multiplied to the second term of 8, right? This positive 8 that we have here. And why do we do that in the first place? Again, we can't do anything in the parenthesis. When we follow PEDMAS, it tells us to follow parenthesis first, but we can't simplify this much further. So what we have to do is we're going to have to look at what's outside the brackets, and this is the concept of multiplication, right? And in terms of brackets, the concept of distributive property is that this -6 or whatever term specifically, or more generally, generally, the term here is going to be multiplied by everything that's inside the brackets. So let's work this out. So if I have this term here that's going to be multiplied to everything inside the bracket, what are we going to get? We're going to get -6 times a, which is simply just -6, right? So this here equals -6a, because I can't simplify. We don't know what a is, right? So a just belongs as a variable. So -6 times a. And what's -6 times 8? Positive 8. Remember, positive, we have a positive number and a negative number, which means I'm going to get a negative number. And 6 times 8 here is 48. It'll be negative 48 in this case. So I'm just going to write minus -48. And that's going to be my answer for question 1 here, right? So I've successfully distributed, but in this case by -6 or whatever is outside the bracket. I'm gonna maybe do some Reddit. So maybe I'll write here. This is outside bracket. Outside bracket. So whatever what was on the outside bracket will now be distributed or be multiplied into the bracket. And what we're doing is we're breaking up this bracket. You look at our answer here. We don't have a bracket in this case. So what we're doing is we are using the distributive property, and we are distributing our term that's outside the bracket into the bracket. So let's do a couple more problems. Let's do the every other one again. So let's do number 3 here in this case. Try to fit it into here for you all. So this is 6 bracket -5 and plus 7. So again, if I'm looking at this problem, what is outside the bracket and what is inside the bracket? So maybe take 5 seconds to do that. Maybe type in chat if you want. So you can tell me first what's inside the bracket and what's outside the bracket. So as you can see here, we have, what do we have? We have a 6, which is outside the bracket. Sorry, this is outside the bracket, and this is going to get distributed into the bracket. So it's going to help break up the bracket. So it's going to be multiplied by this to -5n here, and then it's going to be multiplied by the positive 7. So what do we got? So let's solve this. So it's going to equal, I'm going to try to shift this more because I don't want to make, let's do, it's going to equal, I'm not going to write the equal sign in this case. Actually, I'll write it. So this is a this is positive 6 times -5n. So we have here 6 times -5 first. So 6 times negative 5 in this case would be negative 30, right? Because we have positive and negative numbers can be a negative. So negative 30, and then we still have the n here, right? So it's negative 30n. And then we have 6 times positive 7. That's going to be obviously equal positive 42, right? So I have to write the plus here in this case, plus 42. I can't just write 42 because I need the operation in this case. So I need the positive sign in this case. Otherwise, I'm just going to get something like an answer like this. This doesn't mean anything. Minus 30 and 42 does not mean anything. It has to be plus 42. There should be an operation here that says plus 42. So that's my answer for number 3. So we're gonna go through and do more practice problems, and I'm gonna try to go through these left column ones, and we'll get more familiar with these concepts here. Let's do number 5, and as you can see, it's cumulative, right? What we're doing is we are taking what we learned multiplying and dividing integers, or in this case, it's more so multiplying, and we're applying it to this new concept of distributive property. So number 5 here, this is negative 4 minus 3n times negative 8, and they use this little dot here. I'm gonna just clarify this case. In this case, this dot here means multiplication. It implies multiplication as well. So you don't worry if you ever see this. I'm just gonna write multiply in this case. I don't want to multiply. If you ever see this dot, it's usually it's some sort of multiplication. If you were you're not taking linear algebra, so this dot actually means something else in linear algebra called a dot vector, but we don't have to talk about that. That's not that only applies to vectors, and that's a higher level math course. But in our case here, which is just multiplication. So we have here again, you have negative 4 minus 3n times negative 8. So what's outside the bracket? Again, in this case, outside the bracket is actually on our right-hand side, right? So we have here, our right-hand side is negative 8 here, right? This is outside the bracket, and it's going to multiply into this one, and then into this one. Again, the order actually matters here, because I'm multiplying into the left term first, and then to the right term, right? Because what I could do is I could actually rewrite this, can I not? I could rewrite this as negative 8 multiplied by negative 4 minus 3n. If I want to rewrite it from left to right, right? It doesn't matter if I put it on this side or on this side, it doesn't really matter. So I'm just going to move it to the left side if that helps. So now we can visualize the distributive property much more clear. Remember, it's to here and then to here. So now let's solve, right? So negative 8 times negative 4, we have 8 times 4 here equals 32. The two negatives cancel out, so we have positive 32. In this case, we don't have to write plus, right? Because it's the first number here, we can just write 32. So we have 32 here in this case, and then what do we have left? We have negative 8 times negative 3. We have positive. It's the two negatives make positive, right? So 8 times 3 here is 24. So this would be positive 24, and then the n here, right? So again, 32 plus 24n would be our answer. And then let's go through number 7, 9, and we can keep going. I don't know if they don't have fractions and stuff, but it's okay. Maybe some of the later problems will be harder, but this is pretty easy, right? It's just all we're doing is we're just extending this concept of multiplying integers. So it's actually not a big step towards to what we were doing before, but it is an important rule because this will come in algebra. You'll always see this in algebra, so we always this will come back. So we need to get this foundation down. This is 1 minus 7n times 5. Again, what's outside the bracket, what's inside the bracket? Again, this 5 here is outside the bracket, right? So I can actually rewrite this as, if you want, I can rewrite this as 5 multiplied by 1 minus 7n. I'm just going to clarify, why can I do that? So I'm going to do a little aside here. I can do this because in multiplication, for example, if I have 3 times 4, this equals 12, right? What if I switch the order here? 4 times 3 also equals 12, right? So again, when we're multiplying the products, the order of the factors in this case, not products, the order of the factors in this case don't matter in terms of whole numbers. It does matter in some other stuff in terms of vectors, but it doesn't matter in terms of just numbers or variables in this case. So what we can do is what we're doing is we're flipping the order, right? Instead of 5 times this entire thing, we have instead of this entire brackets minus plus times 5, we have 5 times brackets, right? So again, that's what we're doing. We're simply changing the order, but does not change our answer in this case. So we have 5 here. It's going to multiply to this 1, and then it's going to multiply to this -7, right? So what's our answer in this case? Well, we have 5 times +1 just equals 5. 5 times -7 would equal positive negative would equal -35. And I'll just have to add the n, right? So just -35 n. So it's 5 minus 35 n will be our answer for number 7. Let's do a couple more. I think we're pretty good with this concept. Let me know in the chat if you want me to do a bit more practice with this, or if you want to move on. Honestly, this chat's really it's good for me to kind of gauge where you're at if you're currently watching at home, or if you're watching with the children. Maybe ask them if are you getting this concept and whatnot. Definitely, if you want me to speed up or slow down, definitely let me know in the chat, or if I could move on to a next topic, or if you want me to re-clarify something, let me know. You can always feel free to add questions in the chat, and I'll do my best to kind of answer that for you. Hello, Catherine. Thanks for tuning in. So let's move on here. We have number 9. So let's do number 9. This is 5 times 3m minus 6 here. So again, distributive property states that we have to, this is the outside bracket, we are going to distribute this 5 to both terms, right? So 5 times positive 3m here, and 5 times -6, right? So these arrows really help me when I'm doing distributive property. I don't know if it helps you, the viewers at home, just as I can see, I have 2 steps, right? I have to do, I'll do some blue. I'm doing this first step, the first arrow, and then I'm doing the second arrow. So this is one step, and then the second step, right? So the arrows just help me help you and help me simplify what order we are doing this operation. And again, we're working from left to right, right? This is left and then to right. So again, this obeys PEDMAS as well. So what would you get? So again, you have 5 here times 3m. 5 times 3, you have 15. You have 15. Oh, I see an answer in the chat. Thank you. You have 15m, which is awesome. 5 times 3m here is 15. And this is positive numbers, right? So that's totally fine. So you have 5 times 3 is 15m. And again, the m just kind of stays with the number here just because it's an unknown. It's our variable, and it's kind of stuck to the number as well. And we have 5 times -6 here. 5 times -6. I think this is -6. It could be. It actually looks like a B. I can see why you wrote -5b, A-list, I-list. It's actually a 6, so it's actually 5 times -6 here, which is -30. But sorry if I wrote it as a B. I think 6 and B's look very similar, maybe to you viewers at home. So sorry about that miscommunication there. But it was actually a 6. But if it was a B, if you want to rewrite this question, and I'll do this in red, you actually got the question right? So if we have 5 here times 3m minus b, we can still apply distributive property to both things, right? 5 times 3 here is 15m, and then minus 5b, right? So it changes the answer, but you're actually still applying distributive property. So thank you for that. It's actually still, it is a valid answer if this was b. So again, this would be correct answer if this was b, but it's just a little aside here. And it's nice because what we're doing is we're actually multiplying 2 variables, right? So it doesn't matter if they're numbers in the brackets or variables. The distributive property applies to both things, which is awesome. So this is that was number 9, right? Yeah, number 9. All right, let's do 11. And what I could do is I could actually make up my own problems here, and we can extend this, and we could do maybe 3 terms into the brackets, and maybe I'll do one of those questions and make up my own question for you, so for you viewers to solve at home. So again, this is 5 times b minus 1, right? So again, here, outside bracket is going to distribute into the bracket. So this times, this is a b actually in this case, not a 6. This is a b. I'm going to write this very clearly. This is a b. This is a b, not a 6. And what we're doing is we're doing 5 times b for you. So 5 times b here is just 5b simply. And then 5 times -1 in this case is -5, right? So we just write -5 here. Again, positive or negative number, make a negative number. So let's do maybe 2 more, and I'm gonna do my own problem. But my own problems are usually harder than what they give you in this worksheet. So brace yourself. So this question 13, we have -4 in this case, times -8x minus 8. So what do we have here? Again, this is our outside bracket. It's going to distribute into the first term and then distribute into the second term, right? So -4 times -8. In this case, we have 2 negative numbers, which means the negatives cancel out. So we have a positive number. We have positive 32x2. And then we just have the x here, right? Positive 32, because this x stays. It's going to be multiplied by the 32 here. So 32 times x, so 32x. And we have negative number and negative, right? So 2 negatives here make a positive. So again, -4 times -8 is positive 32, right? Positive 32. We have 2 negative numbers. They're going to cancel each other out and make a positive number. What I could also do is I could actually rewrite this. If this helps some viewers home, what I could do is rewrite this in terms of, this is -4 times -8x first. And then we have -4 times -8. And we can actually split these up and solve. So -4 times -8 is again 32x. And the -4 and -8 here is simply plus 32. And that's where we get the same answer. I don't know if it helps you visualize better in terms of how we distribute. So we're distributing to this one first and then to this one. I don't know if that helps you. I like the arrows personally, but I don't know if you like this method as well, I can do this method. It's just a little bit more work for me, but it's totally fine. So let's do one more, and then I'm going to move on to maybe a bit of a harder question. So let's do 19. 19, we have -7. This is times the brackets here is 5k. K is the variable. We have a letter minus 4, right? So we have -7 times 5k minus 4 here. And again, -7 is going to be multiplied into the bracket. -7 times 5k first, and then it's going to be multiplied by -4. What do we have? We have -7 times 5k. We have a negative and a positive, which will make a negative number. So it's -7 times 5 here is 35. So 35, and then the k is simply just here. -7 times -4. 2 negatives make a positive, so it's really positive. So plus 7 times 4 is simply 28, right? So -35k plus 28 will be our answer in this case. So I'm gonna do instead of doing these last couple ones, what I'm gonna do is I'm gonna actually I'm gonna give you a problem of my own, and then we'll finish up this kind of topic in terms of distributive property, and we'll move on to combining like terms and hopefully percentage change. But this is I'm gonna say this question A. This will be more of a challenge, just because the questions they give you in this worksheet are pretty easy in my opinion. So let's do I'm gonna make this up on the spot. So it's -5 here. I'm gonna multiply by 3x plus a plus 5b. So how would you do this? I'll give you a couple questions. I know some people are in the chat, so maybe I'll give you about a minute to think about this. How do we approach this problem? And you can feel free to type in the chat again, or if you want to answer some questions, or if you want to ask me some questions about this topic before I move on, you feel free to answer the question like right off the bat, or walk me through your thought process as to how are we thinking this. How are we thinking about this problem? How are we approaching this problem? I'm drink my coffee and give you about 30 seconds to figure that out. So what do we have here? Again, we have something that's in the bracket. We have, instead of 2 terms, now we have 3 terms, right? Does that change anything? It does. It just simply adds one extra step to our distribution, right? So again, it's the exact same thing. We have -5, which is is outside the bracket. It's going to distribute. I'm dragging this entire thing. That's so weird. Oh my gosh. Sorry. I dragged the entire equation. Do you see that? That's so weird. Okay, anyways, I have -5 here in this case. It's going to multiply into the first term, into the second term, but also it's going to do the third thing. It's going to multiply into the fourth term here. This is 5b, into the third term here. So we are doing it's a 3-step process. This is the first step, the second step, and then the third step here. So remember, distribution property, whatever is outside the bracket has to go, has to be multiplied to everything that's inside the bracket. So again, that's what we're doing. This is for the first term multiplied. We're going to multiply -5 by the first term, multiply -5 by the second term, and then multiply -5 by our third term. So what do we get? What's our answer here? So let's see. We have -5 times 3x here is what I have negative number and positive number. It's going to make a negative number. This is -15. And we have our x still, -15x. We have a -5 times, this is a positive a, right? Plus a is positive a. So we have positive and negative. It's going to make a negative in this case. So this is just simply negative. What's 5 times a is simply just 5a, right? 5a. -5a. And then what do we have last year? We have -5 times positive 5b. Negative and positive will make a negative. -5 times 5 here is -25. And then we simply have the b here, right? So we have -15x minus 5a minus 25b will be our final answer for this one. It's a little, so again, it's just the same concept, right? Of distributing this kind of term in the outside bracket to whatever is inside this bracket, right? You can think of it as everybody gets a turn on the roller coaster, for example. If 5 was the roller coaster, 3x gets the turn, a gets a turn, and 5b gets a turn. Whoever's sitting, this would be a roller coaster. Whoever's sitting on a roller coaster will get to ride the roller coaster or something like that. So it's just a little metaphor, but I don't know if that helps you figure things out. But again, this -5 here gets distributed to everything that's inside the bracket. So let's do one more before we move on. So there's one more. Let's do a fraction one, because I know some people don't like fractions. I'll do 2/3, maybe times, this is here 6x minus 3 plus 7, something like that. So how do we do this? Again, exactly the same thing. Again, this is just questions I'm making up on the spot, right? We have 2 here. 2/3 here is outside bracket. It's going to multiply into this one, and then into this last one here, right? So 2/3 times 6. What's 2/3 times 6? I'll do a little aside here in red for you. We have 2/3 times 6. What does that equal? 2/3 times 6. I could rewrite 2/3 times 6/1. This I could cancel out 1 here, and this will equal 2. 2 times 2 here is 4. So my answer here is 4. Let's say 4x, right? There's an x here that we can't forget about. So this is 4x. 4x. They're both positive, right? Then what's 2/3 times -3? Let's check. Again, just a little aside here. We have 2/3 times, this is I'll do this -3/1. This cancels out to 1. This cancels 1. We have here, this is -2, right? 2 times -1 here is -2. So again, 4x minus 2. -2. And then we have here did I write a 7? I did write a 7, right? And then plus, what's 7 times 2/3? So this is, I'll do it again. This is in red here. What is 7 times 2/3? 2/3 times 7/1. So 2 times 7 here is 14/3 times 1 here is 3, right? So we have here 4x minus 2 plus 14/3 will be our final answer for this problem, right? So again, we're working with fractions. Fractions also apply in the distributive property as well. So that was just a little lesson on distributive property. It took about half an hour, which is awesome. That's kind of what I planned for today. We're going to look over now combining like terms. We're going to move on to this concept here, combining like terms. So let me write this down. Combining like terms. So what does that mean? What is a like term? Let's define this. We know what the word combining is, a combination of something, a log combination. It's simply just an arrangement of specific numbers, right? So it's a very we know what this word means, but what does like terms mean? So let's define that. So like terms. So what are like terms? Like terms are, I'll do some black. Like terms are terms. Again, terms could be numbers and variables, right? So again, when we talk about like terms, we have two types of terms. In this case, we have variables. Variables are one kind of terms, and we have numbers or constants are another type of terms. So when we're talking about like variables, it's this and I'll specify this. We're talking about like variables, it's variables with the same variable, right? So for example, if I had x, let's put for example, x and 3x here. X and 3x are like terms, and why do we know that? Because it has an x in each term. We have in this first term here we have an x, and 3x we also have an x, right? So I can actually, if I did something like x plus 3x, what would that equal? If I have x here plus 3x, I could visualize this as, oh, this is simply 1x, right? 1x plus 3x, what's 1 plus 3? 1 plus 3 here is 4. And then we have x, right? So I'm combining like terms, right? I had two terms in this case. In this case, I had two terms. I had one term here, one term here. I am combining them to make them one term, right? So I'm simplifying. That's what this means. This thing here says simplifying each expression. That's what I'm doing with combining like terms, right? So again, when we combine like terms, it has to be the same variable. If you think about it, 3 plus 4. These are like terms as well. They're just constants, right? I have a 3 here as a term, a 4 here as a term, and these are both numbers. So I can combine these numbers to make a new one, right? 3 plus 4 is 7, right? I'm combining two terms to make one term, right? It's the exact same thing, but we're applying it usually. When we talk about like terms, it's usually it's usually about variables, but it's exactly the same thing. We're using the same rules as numbers. It's usually with variables. So again, this example of x and 3x. So how do we do specific problems? And let me show you a problem. I'll show you number one. So number one here, this is negative 6k plus 7k. So what would I get here in this case? Negative 6k plus 7, right? Again, these are like terms, right? Both of these have a k in them. So we verify that these are like terms because they share the similar variable. Both k and k are similar variables, right? So, and that's what we can do is we can simply just do the operation. We can do negative 6 plus 7. Negative 6 plus 7 in this case will just give us positive 1, right? So we have 1 here, and then we have k, right? We have 1k, or we can just rewrite this as simply just k, right? It's implied that there's 1k here. So negative 6 plus 7, again, it's just 1, right? So it's just simply just k. 1k is. Let me do question 3. Question 3 is a bit harder. We have n minus 10 plus 9 minus 3. So what are our like terms here? And I'll do this in blue for variables and red for numbers. So we have, what are my two like terms here? I'm trying to find some like terms. So in this case, I have n here, and then I have n as well. These are like terms, they're variables. And then in red, again, I have like terms as well. I have negative 10 here and negative 3. These are like terms as well. So what would I do? What would I get? And again, I'm working from left to right, right? I'm still using PEDMAS. This never changes. So I'm just in blue because I have variables here. So what's n plus 9n? Well, n plus 9n, again, imaginary 1 here. So 1 plus 9 equals 10, right? So 10n. 10n in this case. And then what about my variables, my numbers, my constants? They can also be gathered up in like terms, right? I have negative 10 minus 3, right? What's negative 10 minus 3? What I could do is, I'll write this sign here. We're negative 10 minus 3, right? Minus 3. So again, negative 10 minus 3 here. You could think of them as positive numbers, as I'm adding these two numbers and I'm throwing a negative, right? So negative 10 plus 3, negative 10 minus 3 would equal negative 13, right? So negative 13. So this here will be my answer, right? 10n minus 13 will be my answer. And this is a two-step problem, right? We did the first step here with the variables, so n and 2n. I'm gathering up my variables first. Variables, and then my numbers after. And again, the order doesn't matter because I'm working from left to right, right? So I'm always starting with this this first term here. So the order does matter. So let's just move down. I'm gonna these are kind of easy, so maybe I'll move down to 11 here for the sake of time. Let's do 11. 11 is 5n plus 11n, right? Sorry, 5n plus 11n. So 5n plus 11n, again, my like terms here are, both of them have this n, right? So if they have this n, what I can do is I can simply just add the two terms. So 5 plus 11 here is equals 16, right? So 16, and then I can just drop the n here. So it's 16n is our correct answer. So let's do 13. They're like two-step. Oh, they're two-step problems. I like these. These are much harder. So we'll work towards that. So let's do 13. And I like this one because what this is it's going from easy, and then it's going from a bit medium, and then to like a bit harder. It's like when we talk about harder problems, it's usually just multiple steps, right? And what it is. I have to go to the bathroom. Can I please go? You can sure go. It's your house, so you can definitely go to the washroom. I'm not your teacher in the sense that I'm not enforcing classroom. There's no classroom rules. You can go to the washroom here and do your own business. Again, we're just learning from home, right? Just tune in whenever you want. So this is 11. Let's do 13 here. 13. We have 12r. But thanks. That's kind of cute that you're asking for permission. So 12r plus 5 plus 3r minus 5, right? So we have 4 terms in this case. And do we have like terms? Let's find out. We have 12r. So again, we're starting with the first term. We have 12r. So this is a r term, and then we have an r term here, right? It's two variables, or two terms that have two terms that are like terms that are variables. And then we have here, this is 5 and negative 5, right? This is also like terms as well, but they are numbers, they're constants, right? So how do we solve this? So 12r plus 3r, so it's simply just 12 plus 3, right? 12 plus 3 here is 15. So we have 15, and then we can simply drop the r here, 15r. And what are we left here with numbers? We have 5 minus 5. 5 minus 5 here is 0. So I don't say 15r plus 0. I don't write that down. I simply just get rid of it. So it's just 15r. And that's our answer. This is kind of redundant when we do 15r plus 0, just because there's no point of writing 0. 0 doesn't mean anything in this case. So we simply just get rid of this. So this is just simply 15r. That's our final answer. So let's do, I like these ones because they have distributive property. Let's do 17, and then we'll jump to 21. I think that's how we're gonna do this. Let's do 17. 17, this is negative 3x minus 9 plus 15x. So what are my like terms here? Let's do left to right. So again, negative 3x, so we have an x term here, and then 15x is also an x term here. And then in this case, what are we left with? We're left with this number here, right? This is just simply a number. So it doesn't have any other terms to be like with. So I'm just going to leave that. So we have negative 3x plus 15. What's negative 3 plus 15? So I'm going to do a little side. Negative 3 plus 15 in this case will be 12, right? Positive 12 in this case. Negative 3 plus 15 is positive 12. So it's 12x. And then what we're left with, we're just left with negative 9. There's no other terms to play with, so this is simply just negative 9 in this case. So 12x minus 9 is our answer. All right, time to challenge ourselves. Let's do Let's do 21. 21 is combining what we learned from earlier today and this lesson. So this is a bit of review plus kind of a bit of a challenge as well. So we have -4 plus 7 times 1 minus 3m, right? So how would we do this problem? What are we doing first? This looks like a mess right now. So how do we simplify this expression? This is a 7. What are we doing first? So let's do a distributive property first. Remember, we're talking about brackets. Remember, PEDMAS means we do brackets first. So 1 minus 3m, can we do anything here? No, these are not like terms. This is a constant and this is a variable. They're not like terms. So what do we have to do first? We have to do a distributive property first, right? So we're doing, because we're multiplied, right? We don't do addition first. So we have to do this positive 7 times 1 and then positive 7 times -3m. So what do we get? So we're still left with a -4. Yeah, we haven't, that hasn't changed yet. -4 plus, and then what do we have left? We'll do some blue to show you. So 7 times positive 1 in this case is 7. 7 times -3m, here is 7 times -3, positive negative, gives me a negative number of -21, and then just an m left, right? And then what do we have to do? We have to gather like terms. That's what we learned today, right? So we have, this is 21m, so this is just one, sorry, I'm going to do this in blue and red again because you're used to it. So again, we have this variable of m, and then what about these two numbers? These two are just constants, right? These two are constants. So we can, what can we do? We can gather these constants together, right? We have -4 plus 7, which is +3. And then all we're left with is 3. And then -21m, there's no other terms to, again, to gather. So it's just simply 3 minus, sorry, I wanted to do that in blue. 3 minus 21m here. So 3 minus 21m will be our final answer for number 21. So again, this is a multi-step problem, right? What we're doing first is we did distributive property first. We distributed the 7 to the 1 and to the -3 to both the terms. And then what do? We do gathering like terms, right? So I'm going to do a little aside here. So step 1 was distributive property. And why did we do distributive property first? We did it first because of PEDMAS, right? And that's because we did it. We do multiplication before we do addition, right? So we do distributive property first, and then we call it gathering. So gathered or gather like terms. So that's what we did second, right? So distributive property first, and then gather like terms is the second step, and then we rewrite our expression. So that was 21. Can we do, let's do 23 is tricky actually. I like 23. And I'll show you why it's tricky. This is 23. I don't know if we're going to get to percent of change, but maybe I'll continue there for the next lesson. So 23 is -2n minus, and then bracket 9 minus 10n. So this one's actually really tricky. And why do I say it's tricky? It's because of this negative sign here. So you're thinking, oh, we just do distributive property, right? Or we just do PEDMAS first. 9 minus 10n, we can't do that. So we're doing, what we're doing is we are going to do distributive property first, right? We have negative here. And then what we're doing is we're going to distribute this negative. You can think of this as imaginary -1 here. Right? This imaginary -1 here. We have to distribute it to the first term and then to the second term here. So this is why it's tricky. It does, there's no number here, right? But we still have to do distributive property. So this negative applies to this first term and to the second term here. So how would we do 23? So what we have first is we have, so let's distribute first. So we have -2n here, so -2n. And I'm going to do this in blue again. So -1 times positive 9 will just simply give me -9. I'm going to do constants in red like we've always been doing. So this is -1 times 9. Positive 9 is -9. And then I have, this is -1 times -10n. It simply just flips the sign, right? So two negatives make it positive. This is now positive. So plus, I want it blue, sorry. plus 10n. Now we're gathering like terms. We have negative 2n, so this is again my n term. These two are my n terms, and then this is simply the constant that's left over. So what's left here? I have negative 2 plus 10 would equal positive 8, right? Positive 8, so 8n, and then the constant is just left by itself. So 8n minus 9 would be our answer for this case. So let's do one last one for this question. I'm gonna pick 27 because this looks a lot of work. There's a lot of brackets. I think it'll be a challenge, and then we'll finish up here, and maybe I'll introduce you percent of change. Actually, maybe I'll finish this and then review, and then we'll do percentage change probably for next class. And this is, again, percentage change it is not like a very big thing, but it's still good to know. But so maybe I'll do 2 more questions here, and we'll review what we did today. It's 27. We have negative 10, and then 1 minus 9x plus 6 times x minus 10. So how do we do this? Again, there's a lot of brackets here, so there's a lot of stuff we can do. So again, you see these brackets. So again, outside term and inside terms, distributive property. So we have negative 10 here. It's going to distribute at 1 and distribute to a negative 9 here. This 6 is the outside bracket for these two, right? So this 6 will distribute to the x, and this 6 will distribute to the negative 10 here, right? So we have 2 distributive properties going on, right? So this is good. It's a lot of work, but it's good. It's good work, right? So we're working from left to right like always. So negative 10 times a positive 1 will simply just give me negative 10. So negative times positive still is negative. So negative 10 here. Negative 10 times negative 9 is positive. So 10 times 9 has positive 90. Positive 90x. And then what do we have left? So we distributed the first part, and then we have to distribute the second part, right? So what's 6 times x here? It's just positive 6x. So just plus 6x, and then 6 times negative 10 here. So positive negative, make it negative. So 6 times negative 10 here is negative 60. And then what can we do? We can gather some like terms, right? We can do this. We'll do the constant first. We're working from left to right. So let's find all the constants. It's negative 10, not a constant. Negative 60 is a constant, and my x's are my variables, right? So this 90x here and 6x here. So what am I left with? I'm working from left to right. So negative 10 minus 60, what would that equal? Negative 10 minus 60 will equal negative 70, right? I'm adding the 2 numbers, and I'm throwing the negative sign at the front. 10 plus 60 here is 70, and then throwing the negative here. So this is negative 70. And then I'm left with 90x plus 6x. It's just 2 positive numbers, so 90 plus 6 here is 96 plus 96x, and that will be my answer for 27. Let's do one last one, and then we'll call it a day. Let's do 29. I like these problems. They are kind of very fun, because what we're doing with distributive property is we're kind of expanding, and you might hear that term a lot. We're expanding the brackets. We are breaking down the brackets, and we're expanding. So again, we have this problem here. We have 2 brackets. We have 2 outside brackets, right? So outside. So this negative 3 here is outside the bracket. It's going to times into the bracket. So again, being distributed. This 5 here is being distributed to the b, and then to the 2 here. So what do we have? Negative 3 times positive 10. You have negative 30. Negative 30 and the b here. Negative 3 times positive 10 would give me negative 30. Plus, we have 5 times b, simply just positive 5b. And then 5 times 2 is obviously positive 10, right? So we have these 4 terms. So let's work with the variables first, or whatever, because this negative 30b is my first term, so this is a variable. Not a variable. This 5b is also a variable. That's not a variable. Negative, these are then my constant, right? Negative 30 and positive 10 are my constants here. And now what we can do is we can gather like terms. Negative 30 plus 5 here. Negative 30 plus 5 will be negative negative 25. Then we have the b here. And then negative 30 plus 10 in this case is negative 30 plus 10 is simply just negative 20, right? Because by adding 10 to a negative number, it's going to become less negative. So this is negative 20. So that's kind of what we did today. So just a little review and just a little recap of what happened today and what we did, because we did cover a lot. So let's I'm going to zoom out here and show you what we did today. So as you can see, we did a lot of math. How much math did we do? We did all this. That's crazy. Okay, so let's let me zoom back in. So we reviewed. So today this was just a review. We did a little bit of review, and I did a little bit of division because we didn't do much division in the last class, the division of negative numbers. And what I introduce you is this concept of distributive property, right? So again, this concept of distributive property is we're distributing or spreading out so as to cover everything. So in this case, we're spreading out this outside term of negative 6, and then we are multiplying it into the brackets. We are breaking down this bracket. We're expanding, right? So what we're doing is negative 6 is we're going to multiply it into the first term, and it has to be multiplied to the second term. We're spreading out this negative 6 so it covers everything inside the bracket. So negative 6 times a would be negative 6a, and then negative 6 times positive 8 would be negative 48. So that's the concept of distributive property. So we did a bunch of practice problems with this kind of concept. And I gave you some of my questions as well, a bit harder when we have 3 terms in the bracket. But again, it does not change everything. It just adds simply one step to our distributive property, right? Again, the outside bracket or the outside term is still being distributed to everything inside the bracket. And then what we did in the second part, or the second half of the lesson, is what we did was we did combining like terms, right? So with like terms, we defined it as variables. It could be variables or numbers, but again, they contain the same variables. So let me redefine this now, because now we know how to do this. So they contain same variable. So a lot of students, I'll do this in red. A lot of students, what they choose to do is, if I have, for example, 10x plus 5y, what a lot of students may do is that they simply just, I can just simply do 10 plus 5 is 15. X plus y is x, y, and that's going to be my term. This is not correct, and this is wrong. And why is this wrong? This is wrong because I have two terms. I have 10x plus 5y that are different terms, right? This one has x, and this one has a y. Remember, they're not the same variable, so I can't simply just do the operation of addition and simplify them. I can't stop 10 plus 5 is 15 and then x plus y or x times y. That's not correct. When we're collecting like terms, we have to make sure they are the same type of variable. So that's just a little misconception. This here, I actually can't simplify this this expression here. 10x plus 5y, I can't do anything with this expression. What I could do is I could do something called, I could take out or factor. But we don't want to talk about factoring. Factoring is kind of the opposite of distributive property, where what I do is I find something that's this is a little sneak peek of what we're doing further down the course. But what I can do is I can find something that's common between these two terms, and this is just a little sneak peek. 10 and 5 have a common, their greatest common factor is 5, right? So I can do this. I can take out 5 and I can recreate brackets. So I'm dividing all these terms by 5. So it's 10 divided by 5 is simply just 2. I still have the x. 5 divided by 5 is simply 1, but I still have the y. So it's just positive y here. And what I'm doing is I'm factoring. So I'm going from this back to, I'm going from here to here. And as you can see, this is the concept of factoring. And if I did the opposite, and if I did distributive property, I would go back here, right? I would do 5 times 2x would equal 10x, 5 times y would equal 5y. So again, this, if I'm going backwards, it would be the distributive property. Going forwards, it's expanding. But don't worry about expanding for now. We'll do it in a much later video. And then today what we did was we did a bunch of questions with like terms, and then we kind of put it all together near the end of the video when we did distributive property first. And I think I wrote this down here. We did distributive property first here, and then we gather like terms. So So I hope you learned. I hope you viewers home, especially, thank you for tuning in to today's stream about for linear algebra 1. What we're gonna do probably next lesson is we're gonna start with percent of change. Maybe work through a couple of questions. I won't spend too much time on this, and then we'll move on in algebra 1. So again, as always, thank you for watching, and I hope you have a great day.